Hello everyone, thank you very much for watching this video. My name is Juan Sebastian Carrillo. I'm a PhD student in computational science at San Diego State University, and I work under Professor Jerome Gilles. The title of this presentation and of this project is Turbulence Mitigation on Images using GAN models. So the first thing that we need to know is what is atmospheric turbulence. Atmospheric turbulence is uh, distortions and modifications that we can see on the images due to the fluctuation of the air when we take a picture. And pictures are everywhere. So be able to handle this problem is very important for the current civilization that we have, that it's including images everywhere. So the problem to try to avoid having this kind of problems in on images is that to train a model, in this case with artificial intelligence, we need images that include distortion, atmospheric turbulence, and images without it. But when we take a picture, we already have it, and we cannot just avoid having the atmospheric turbulence in an image. So what we're going to do is that we are going to work with a database that is simulating the atmospheric turbulence and will give us the possibility to have one image without turbulence and the same image with turbulence. So we can teach the model, and the model will learn about this turbulence on the image. In this case, we are using SOTI's database that is created by the Professor Jerome Gilles at San Diego State University. It consists in 215 images of Eurasian cities, and when they apply the different algorithms to simulate the turbulence, they get more than 500,000 images with atmospheric turbulence, and we have the original image to be able to compare. In this case, we have that in the state of the art, people usually separate the atmospheric turbulence into two parts. The first part will be the distortion, that is this kind of curves that appear where you're expecting a line. We have this kind of curves that is moving the structure, the natural structure of the images, and we also have blur. The database contains distortion and blur depending on different parameters. In this case, we have L, that is the distance, and in other case, we have C squared, that is the amount of turbulence that they are applying to the images. So we can use these images to train the models. And the model that we are using is the GAN model, Generative Adversarial Network. It consists into two architectures. In this case, generator, discriminator. The main idea of this is that the generator will take an image, will generate something, and the discriminator will try to identify if that image is real or fake. This generator is taking blur images, and the output of the discriminator, or what we are expecting the discriminator to do, is to deblur the image, create something very soft and clear, and the discriminator will identify if the image has blur or not. So the first thing that we have to do is to train the discriminator. The discriminator will learn how to identify images without or with blur. And the architecture it consists in convolution layers and a neural network that is going to give us only one output. And the generator, well, the discriminator, we train it first, and then we put everything together in one model, and we train the generator by using the discriminator output. And this is giving us some good results. We can do the stratification of the dataset by the SSIM. The SSIM is an index that is telling us how similar is an image compared with the original image. So in this case, we have these bins from 0.1 to 0.8. Something that we can see over here is that the biggest amount of images is close to 0.6, 0.7. When the SSIM is close to 1, is better because the image is more similar to the original image or the same. When it's 1, is the same. So something that we can see over here is that most of the images that we have on the dataset are images that are not very affected by the turbulence. And it is something very important because when we see the results, the improvement that we get when we apply the generator to the images is that the images that are close to 0.6 are getting the best improvement. This could be due to two things. The first is that the biggest amount of images are close to 0.6. That means that the network will learn more from this part. And two, because close to this area, the images are still having enough information and good information to do the reconstruction of the original image. So the improvement is We are expecting it to be better, and it's better in this area. This is another stratification of the data set. Depending on the z-square, that is the amount of turbulence, we can see that the improvement is also bigger here, is greater here. And when we are getting worse images to reconstruct, it's harder because we don't have enough information. And this is depending on the distance. Thank you very much for watching this video. Bye-bye.